Tonight's video is section 3.4, the second derivative test. Your homework from this is 27 through 39 odd and question number 40. The purpose of the second derivative test is to find relative extrema. So let's go ahead and go through this. Let f be a function such that f prime of c is equal to 0. In other words, critical numbers found by setting the first derivative equal to 0. And the second derivative, f double prime, exists on an open interval containing c. So that means in this open interval that contains the c on the first derivative, it can have no sharp terms. Otherwise, this would not exist. If I have that, then number one, if f double prime of c is positive, that y output is greater than 0, then f has a relative minimum at c f of c. Remember, we're looking for relative min or relative max on the original function. 2. If f double prime of c is negative, less than 0, then f has a relative maximum at c f of c. And then number 3, if f double prime of c equals 0, the test fails and we must use the first derivative test. So this test doesn't work all the time, the second derivative test, like the first derivative test does all the time. So let's go ahead and let's go through an example. Let's find the relative extrema for f of x equals negative 3 times x to the 5th power plus 5 times x to the 3rd power. Well, the first thing I need to do is take the first derivative. In which I did that, brought down the 5, brought down the 3. And now I'm going to go ahead and find the critical numbers by only setting it equal to 0. So I'm going to set it equal to 0. I'm going to GCF negative 15x squared, which leaves me x squared minus 1. Factor that further. Set those equal to 0. I have 3 critical numbers. Next, I need to take the second derivative. So the second derivative, I bring down the 4, that's negative 60, I bring down the 2, and I decrease the powers by 1. So there is my second derivative. Now, by the second derivative test, so now I'm applying the second derivative test. That's what I'm doing right now. So I'm going to take those 3 critical numbers that I found, and I'm going to put them, I'm going to evaluate them in the second derivative. So I did that, and I got negative 30, in which that is negative. What I did here to the side is I took that critical number and I put it back in the original function. And we'll deal with that in a moment. In the other critical number, negative 1, I put it in the second derivative, and I got a positive output. I went ahead and also put negative 1 into my original function. F double prime of 0 equals 0. Remember, that was one of my critical numbers. Well, this is where the test fails. The test fails. So, conclusion. By the second derivative test, since f double prime of 1, what was that again? Is negative, less than 0, then f has a relative maximum at the ordered pair 1, 2. It's on my original function, on f. since f double prime of -1 was positive, then f, my original function, has a relative minimum at -1, -2. Right? I put a negative on the original function. Now, the one that failed, the first derivative test, is what I have to do. So I went back to the first derivative, and I went ahead and on this line, I used the first derivative test. I put all my critical numbers, -1, 0, and 1. So I had 4 test points. On the 4 test points, I put each one of them into here, and I got positive, negative, negative, positive. So the only one that I could not answer by the second derivative test was the critical number 0. Here. F has neither a max nor a min at x equals 0 because the signs are the same. Thank you.